Welcome to Roadmap 1102, Virtualizing SAP Workloads with SUSE KVM. My name is Gerion Fay. I'm in the SAP Solutions team based out of Waldorf, the SAP headquarters. And I brought with me Arne.
Oh, hi.
Who is doing
Arne Wolf. I'm in Gerion's team, a SAP Solutions architect. I'm currently working on SAP HANA on KVM.
So, we want to give you a little overview on what's going on with SAP and virtualization and on SUSE. This is a roadmap session, so the safe harbor statement. We are trying to tell what we think is going to happen. But of course, things can change. So this is why we have this slide here. I will talk a little bit about SAP and virtualization in general, and then about the supported scenarios. Then Arne will talk a little bit about what we are doing there and why it's really hard to do, and give an outlook on the roadmap. And then we will do some feedback and Q&A. I want to give you a lot of opportunity to ask questions. But first, I have questions. Who of you is running SAP applications? Okay, so the right side is the SAP side. So the right side knows what SAP nodes are. So for the left side, SAP nodes are kind of knowledge-based articles, and they tell you what is supported and what's not supported. I will talk a lot about SAP nodes, so that's why I'm asking. And so, SAP virtualization. Why do you want to virtualize at all? So virtualization brings advantages in that you can better utilize your hardware, that there is less power and cooling, you need less rack space. The management is simplified because you can just move virtual machines around, and this brings you more agility and productivity. So it's not even a question why you would virtualize anything. It's a standard in data centers today. So the question is not why, but rather how do you virtualize? SAP applications and SAP databases are usually running the core of your business. So it's really important that whatever we do on the infrastructure side, on the virtualization side, ensures the integrity of the data in your SAP systems. Because if you lose this data, you are done. Your business is down. Also, if there are problems, we need to make sure that we have the right tools in place and the right processes in place to be able to support you, to be able to find root causes and fix what has gone wrong. And especially with SAP HANA, it's also about performance. SAP HANA is a database that's all about performance. So for all these reasons, SAP requires us to validate our hypervisor. And when I say validate, it's a validation. A lot of people confuse validation and certification in the SAP space. So what you have as a certification is usually done by the SAP ICC. There are fixed scenarios that you can certify against. For example, a backup integration. It comes to mind, or things similar to that. There are are fixed test plans which ensure some functionality, and then as a partner you can perform those tests being supervised by the ICC, and then in the end you get a nice certificate and a listing on a website, which is perfect for marketing. But this is not what we want, right? We want to make sure that it actually works, that we have the best solution, that we have a joint support between SAP and us, so that you as a customer have the best experience with it. So a validation is driven by the SAP product management or development teams. And yes, we also do a lot of testing to ensure the functionality and the performance, but it's more like a joint effort between us as a partner and SAP. And then SAP will issue a support statement in form of an SAP note, and you get joint support. So if you have an issue, you just open a ticket with SAP. And you don't have to care on which level the problem is. We work together with SAP in the same support system to get you a resolution. The virtualization market has been dominated by VMware in the last years. So what options do we have for virtualizing SAP? Obviously, VMware, I just mentioned, they have a really broad coverage in scenarios, and they are a clear leader in the space. We also have Nutanix. They have their own hypervisors, the HAV, and also a pretty broad coverage. They do need special HCI hardware, and because of that, the VM sizes are limited. Then there is Red Hat. OpenShift virtualization is not supported by SAP. Red Hat virtualization was supported by SAP, but it's at the end of its life cycle, so it's not supported anymore by Red Hat. And there's Red Hat KVM in Red Hat Enterprise Linux, but they have decided to not validate that for SAP HANA. And we are here because we have SUSE KVM into the Linux Enterprise server, also for SAP applications, which is validated for both SAP HANA and non-SAP HANA workloads. Again, there are a lot of footnotes which you can probably view in the recording of this session. So what is supported? KVM virtualization, as it is in SaaS for SAP applications or plain SLAS, is supported to run SAP applications and database instances since a very long time. This goes back to SLAS 11 SP1 or later for production workloads. So you can virtualize your production workloads on SLAS and SLAS for SAP using KVM. I have here a couple of SAP nodes. The first one, and this is the mother of all virtualization SAP nodes, is the 149-2000. If you have any question on what's supported and what's not supported, this is where you start. It contains a lot of information. It contains a lot of pointers to other SAP nodes, for example, to this Linux sub on SUSE KVM SAP node. And this states that what I just said, that on SUSE KVM you can virtualize your SAP applications and databases, IBM DB2 and the SAP ASE database are generally supported. Then Oracle is supported, but not for production. And SAP HANA has some more restrictive validation requirements. So all your application servers, those databases listed here are supported. Easy peasy. This you can just virtualized. HANA is special, and all of what from now on we say is just applying to SAP HANA. All the restrictions I will talk about just apply to SAP HANA. Or the application servers, you can do whatever you want. It's supported. So having said that, SAP also supports SUSE KVM virtualization for SAP HANA. Starting with /for SAP applications or plain /12 for non-production workloads. So that's a no-brainer as well. For production, it gets really complicated. For production workloads, we have to validate specific hypervisor versions for specific scenarios. And just from the volume or the number of SAP nodes I have listed here, you can tell that it's not only the hypervisor version, which is in our case the service pack level, but also for hardware generations. And again, there are some interesting SAP nodes which gives you a little bit of an overview on what's supported and what's not supported. I will talk about this just in a minute. What is fairly new is the workload-based sizing for virtual environments. So we support this now too. What this means is that in a traditional HANA environment, you have a fixed ratio between memory and the CPU power. There are only certain CPU types allowed, and there's a pretty strict architecture that is supported by SAP. With the introduction of the tailored data center integration, version 5, SAP is allowing a more flexible way of sizing SAP HANA. So under the conditions that you are running on certified HANA hardware, you have a validated hypervisor, you can deviate from this strict appliance-like model to a more workload optimized sizing. So you can do an analysis of your workload, which results in some very specific requirements, like the SAPS, the subs requirements. This is a measure for CPU power, for example, and memory, and so on, and then have your VMs more flexible, and also the host machines that you run this on. Again, for details, there's more in the SAP note mentioned here. A SAP HANA hypervisor validation has a certain scope. So this validation is valid for a certain scenario. And there are multiple dimensions to this. So the version of the hypervisor, which is, as I said before, the /sp version. So basically the version of the kernel, the version of QEMU, the version of libvirt. Then we have the CPU architecture, so Skylake, Cascade Lake, and so on. The number of CPU sockets, the amount of memory we want to support, the storage type, can be fiber channel, can be NFS, or direct attached storage, and then the different validation scenarios. A single VM on a hypervisor host, or the multiple VMs on a hypervisor host, live migration, VM level HA, and so on, which are depicted here. If like any of this changes, it's a new validation. So if I change the service pack, I have to do a new validation. If I change the CPU architecture, I have to do a new validation. If I want to go bigger with the CPU sockets, I have to do a new validation, and so on. So it's really a massive amount of testing and validation that we have to do in order to support this. And we are doing this for a certain reason. And this is what Arne is now talking about.
Yes. Hello and welcome. Well, we're doing it for that reason that I have a job. No, jokes aside, what Gerion just said is that a validation for SAP HANA is a lot of effort, and I will go into some detail about it. First of all, why are we doing this? Goal is obviously always customer satisfaction. I mean, some of you probably are customers. When you set up a system, especially a system that is so deep in your IT core and should not be interrupted, you want to calculate what it means to virtualize that and also predict the risks involved. With the validation that is required by SAP, we basically do that. So we make sure that everything that runs on a validated hypervisor runs as expected and with a very well-defined amount of performance that has to be transported through the abstraction layer. The challenges, well, the first one, and it's also the benefit with every validation that we do, we create a well-defined environment to run SAP HANA inside a virtual machine. So we give you precise instructions about the configuration of the hypervisor and the virtual machine to squeeze as much performance out of a system as possible. Two, that's the challenge, transport near bare metal performance through the abstraction layer. The scope of such a validation is this. We have to run 4 different benchmarks, and let me go through them. The first one is called HCMT. Some of you who have worked with SAP software and benchmarking in the past may know it. It's a hardware and cloud measurement tool. It's basically a storage test. This is the only one where we use the absolute values of what has been measured inside the virtual machine. This usually is the easiest one, as since the spinning disks were gone from servers and SSDs and NVMEs came in, HCMT usually is green. The second one is the performance barrier test, which is the first one of those where we have to show that the performance of the bare metal system is not a certain amount of percentage higher than the virtual machine running on the same host. This is a test where the database already is available, and the database is stressed in different ways. 2 tests, one bare metal, one virtualized, and if we stay in a certain gap, we are green. That's the same for the other 2 tests. One is a set of mixed workloads stimulation to transactional and analytic, and the last is a benchmark running in the Business Warehouse Edition for SAP HANA. In all of them, we need to show that we stay inside that allowed performance gap. When we are done with that, we have validated that one single VM can run on one single hypervisor host. All the other scenarios that Gerion talked about have to be validated through a subset of those benchmarks with different settings. So live migration, for example, you have to show that the database is persistent after migrating while a subset of these tests are running. For a multi-VM scenario, we have to show that the performance gap between one single VM running on the hypervisor between multiple VMs running on the hypervisor is not higher than another certain percentage. You can imagine that that takes time if you don't get your desired performance values right away. Then you start looking for the needle in the haystack. Not entirely, but you get the point, I think. The general pain points that we have, this is more a general statement. The general pain points with virtualization in general, when you want to show that you can transport performance through the abstraction layer, basically these 3 points. CPU latency with activated boosters. The problem here is that the boosters sometimes do unpredictable things, and during an analysis of benchmarks, when you have a peak in one of the result sets and another peak on a different in a different time frame on the second result set, you can kill your goal. So boosters are not very favorable in a while you're measuring your performance, but that's more a side statement. Network latency is a problem, especially when you use virtualized network technologies. Bridging works most of the time. Sometimes you even have to go the way that you pass through your PCI network device to the VM to minimize network latency. And storage latency on the write performance mainly. We have some pain with devices that are passed through via Word I/O. We have other ways of other ways to pass through devices to a VM, but Word I/O is a general problem currently. On the CPU side, this is a graphic that shows what we are doing to optimize performance here. In short terms, what is done is that we clone the NUMA architecture of the hypervisor host and present the exact same NUMA layout to a virtual machine. This works for one single big VM and multiple VMs, as multiple VMs at the current point in time only are allowed to fill one socket. You just clone that socket then. In a multi-socket scenario, you would clone the desired number of sockets into the VM design. That's possible with KVM. Also, you pay attention to the memory layout. You want the memory just in a bare metal environment. You want the memory to be accessible by the right core. So you don't use a CPU core from socket 1 and attach memory from socket 4. It makes no sense. So you pay attention that this is the same in the virtual environment. This is a rough overview of what we're doing on hypervisor level to make sure that the performance is transported through the abstraction layer. Hyperthreading is enabled. We are pinning CPU core, physical CPU cores to virtual CPU cores, or vice versa. We enable NUMA awareness in so forth that we clone the new NUMA topology, as I just said. We are able to use roughly 90% of the actual available physical memory for the VM. The real number is currently more close to 92%. That can be used for virtual machines on top of the hypervisor. We are backing the memory of the virtual machines with huge pages of the size of 1 gigabyte. We use SRIOV for networking and PCI pass-through for fiber channel storage and direct attached storage. Currently, I'm testing if we also can use SRIOV on fiber channel storage devices, but I'll update the proper channels if so. And for NFS storage, there's something missing. We also usually use PCI pass-through on the network device. All of what I just said is included in our SUSE best practices guides for SAP HANA on KVM, which can be downloaded there. These documents include everything you need to run virtual machines on top of your hypervisor and use SAP HANA inside of it. Every configuration item on hypervisor level, on virtual machine level, and on guest OS level is contained in these documents. Currently, it's documents. So for every scenario that Geron explained, there's one document containing the instructions that you need. We may change that in the future for better visibility.
So we are going through a lot of hoops and loops and to really achieve optimal performance, to really achieve those KPIs that SAP mandates on us. Arne can talk hours about all these technical details on how to bring everything to the max in the kernel, in the I/O path, everything. So it's really a big task. So when you look at the outlook that he's giving now, keep that in mind. So the question is, just for the people who are not here, the question is, what's the preferred hypervisor of SAP? And with all those things that Arne just mentioned, does it even make sense to virtualize? Is that your question? Yeah. So SAP does not have a preferred hypervisor. They make sure that we as a partner provide a proper solution, as I mentioned before. So that's the same thing for VMware. That's they have to go through the same process. That's the same for Nutanix. They also have to go through the same process. So we are all being treated equal. Does it make sense to virtualize in this specific way that we are describing in our best practices guide? Maybe not. But this is how we achieve the KPIs that SAP demands from us to be a validated hypervisor. In our best practices guides, we have also hints on if you do things differently, what does it mean for the performance? For you, it might be completely okay to have a performance gap of 15% maybe. if that helps you with your operations. But that's not what we have to do for the validation. I don't think that if you are having a problem and you open a ticket with SAP, that they will first look at how things are configured and then say, no, this is not according to the best practices. Unless maybe it's a performance problem. But in general, I don't see a problem there if you do things a little bit different. So the question is if a customer would want to migrate from VMware to KVM, how difficult this is. We do not provide tooling for that. It is possible. We had a proof of concept on the last SUSECon in Berlin that shows how this can be done. So that might be a job for SUSE Consulting to help you with something like that.
I continue with the roadmap and outlook to clear this up.
Thank you for the segue. Yeah.
This is how it looked in the past, looks now, and will hopefully look in the future. The scenarios we validated in 2022 was a Skylake, a single VM on one single hypervisor host. In Cascade Lake, we added multi-VM support. With Sapphire Rapids, we are aiming at the same for 2-socket, 4-socket, and 8-socket. The reason why we have this arrow here is up until Cascade Lake, you needed one validation to validate everything in Cascade Lake. So you used the biggest system you want to validate, you validate it, and then all the smaller systems were automatically included in this one validation. As of now, as of Sapphire Rapids, SAP decided that this is not sufficient any longer, and we need to validate every scenario, every distinct socket size. So we validate 2-socket first, then we start over, validate 4 sockets, and we are currently working on 8 sockets. So 2 and 4 sockets on Sapphire Rapids is done. 8 sockets is work in progress. Simultaneously, we're working on Emerald Rapids 2 sockets, as there are only 2 sockets, I think. And in the near future, we will work on Granite Rapids as well. From a socket size and socket amount and memory size perspective, it looks like that. So Skylake was 4 sockets, 3 terabytes of RAM. Cascade Lake, 4 sockets, 6 terabytes RAM, both up to statements. On Sapphire Rapids, we have completed in the last year the 2-socket 4 terabyte RAM validation and the 4-socket 8 terabyte RAM validation. And again, working on 8 sockets 16 terabytes, as well as on 2 sockets 4 terabytes in the Emerald Rapids dimension. Granite Rapids is coming. We are not sure at the current point in time which sizes we will have to validate there. Was that? Okay. What I just said in a different form, but let me go on the storage types a little bit. So in addition to the different scenarios, the different socket amounts, and the different memory sizes, we are looking at validating all 3 storage types. So you as a customer can choose between using direct attached storage or fiber channel storage, or storage that you access via NFS. In the Sapphire Rapids and Emerald Rapids dimension, we will use /15 SP5 as hypervisor operating system.
And you might wonder why that is. I mean, SP5 is not really the latest server spec, right? The thing is, when we started this journey here with the 2-socket, remember we have to do the 2-socket and then the 4-socket and then the 8-socket. When we started the 2-socket, the SP6 was not available yet. And we can't change the hypervisor version in between. So we will do another validation of the whole thing with SP7 at some point in time.
That was it. Feedback and yeah. I would like to give you the microphone if that's possible, so we have it on the recording that we do. I'll start here.
Yeah. First of all, thank you for all the information. I have a question not about the host size, but the VM size, because some of those notes also specify how big or how small the VMs can be. And right now, I don't think you can do like, so the smallest VM that is supported is mapped to 1 socket.
Yes.
So that can be quite big with the latest generations, and especially if you are doing virtualization, when what you want to do is to reduce the number of hosts, so you try to accommodate as many VMs as possible in one physical server. So I guess, the question is, are there any plans to support like half-socket VMs like VMware does and other, something smaller than 1 socket? Because, I, as a solution architect, when I try to architect something using KVM,
yes.
and just being transparent, so given the situation with the licenses, with VMware, all that, there are many requests now from customers to use KVM instead. But I have a little bit of a limitation there because the smallest VM for production is too big. So,
yes.
Any plans on support to support half-socket VMs or smaller even? Yeah, that would be great.
So we are looking at half sockets. This is something that we have to test before I can put this on the roadmap or something. We can't go smaller than this, unfortunately, because that's an SAP requirement. It might be for future generations that you can do that, but it's kind of a limitation that all the hypervisors have because of the way how the SAP HANA folks want us to run things. Hope that answers your question.
Yeah, a couple of questions. We've been hearing a lot about SUSE virtualization this week. That's not what you're talking about here. You're talking about KVM on SLES for
Yes.
SAP. Anything in the future to seek certification or validation on SUSE virtualization?
How should I put this? There is this kind of technology, KubeVirt, that's used in SUSE virtualization, that's used in inverted OpenShift virtualization, that poses a kind of a support issue for SAP. In an SAP virtualized environment, there is a requirement that SAP can monitor from inside the VM with some metrics from the host system. And the way that KubeVirt and with that SUSE virtualization works prevents that. Because you have a VM inside a container on the hypervisor host, and that container prevents that with the tooling that exists, SAP can look into the host, how the host is doing, what the processes are running on the host, what the utilization is on the host, and so on. And this is a support issue for SAP. And
So
that's
in
why
other words, you're saying
that's
no.
why they are not allowing this.
At the moment. And
So
the
it's not
second
up to
question,
us.
And the second question is, this may just be my naivety. You talked about all Intel processors. Are any AMD processors supported?
SAP HANA in general is only supported on the Intel CPUs and on IBM Power.
Okay, thanks.
Not on AMD. So that's not a virtualization topic. That's just how HANA works.
Will SAP support running application servers on SUSE virtualization, or is that also not?
That's the same issue as I just explained, that SAP can't look into the host from the VM. So that's a no to that too, unfortunately.
So there has been talk about SAP not having a containerized application or workload. Is that the same concern, that the containers are smaller, perhaps more efficient than VMs?
So the architecture of an SAP system, of a traditional SAP system, with the application server, the ABAP part, and then the database, and is not really suited for being put into a container because of the way that the components interact with each other. You would have to re-architect the whole thing. That's not going to happen. However, there are new workloads, for example, the Edge integration cell, that are cloud native. And that's why we announced today a range of SAP applications for those kind of workloads. But the traditional workloads will not run containerized. If there are no further questions, then thank you for your time and